Objective 14, be able to use C1 times V1 equals C2 times V2 to solve titration or neutralization problems. So you have an antacid tablet with a mass of 0.300 grams and it contains sodium bicarbonate. But we don't know how much that 0.300 grams is actually what we call the active ingredient or the sodium bicarbonate. So it's added to 25 cc's of 0.125 molar hydrochloric acid. After the reaction was complete, the excess hydrochloric acid required 3.5 centimeters cubed of 0.2 molar NaOH to neutralize it. So calculate the percentage of sodium hydrogen carbonate in the tablet. So this is a lot to take in. So again, I'm going to make this a little bit smaller so that we can concentrate on the numbers we need here. So I've written the two balanced equations. Now NaHCO3 plus HCl, it's a little bit tricky to figure out, but it's basically a replacement reaction. So the Cl is going to bump the CO3 off. And when it does that, that leaves you NaCl, because Na and Cl combine in just a 1-to-1. And then the H gets together with the HCO3, the hydrogen carbonate, which is a polyatomic ion, and it would form H2CO3 briefly. And if you just left it as H2CO3 on your balance equation, that would be just fine. The reality is it'll break down into H2O and CO2. But as far as we're concerned, the molar ratios are going to be the same. Everything is 1-to-1-to-1 here. The other equation is that excess HCl then is titrated with NaOH. And again, it's a 1-to-1 ratio. So what do we do with all this information? Well, we start up at the top here and we look at how much HCl was added to this antacid tablet. The HCl was deliberately added in excess so that we can assume all the NaHCO3 reacts in this vessel. So if I look at 25 cc's, or really it's 0.025 liters of HCl times a molarity of 0.125 moles per liter, we are starting with an excess amount of HCl equal to 0.00313 moles of HCl. And we know that's more than we needed. So how much more was it? Well, then I go down here and look at what happened when I titrate with NaOH. I used 3.5 or 0.0035 liters of NaOH with a molarity of 0.200 moles per liter. Or in other words, I use 0.0007 or 7 times 10 to the minus 4th moles of NaOH to titrate the HCl. And since there's 1 mole of HCl per 1 mole of NaOH, this is also 7 times 10 to the minus 4th moles of HCl in excess. So now that I know how much I started with and how much I have left over, I could take my 0.00313 moles that I originally started with and subtract the 0.0007 moles that I know I had left over. And I come up with 0.00243 moles of HCl that was consumed or reacted with the NaHCO3. So this is important because if 0.0243 moles of HCl reacted back in my original reaction, then I can look at my molar ratio here and I see that it's 1-to-1 between the antacid and the HCl. So that means I must have had 0.00243 moles of my NaHCO3 that reacted. So now how do I finally get to my percent? I know I have 0.300 grams in the antacid tablet, I take this 0.00243 moles times the mass of sodium bicarbonate, which happens to be 84.02 grams per mole, and that gives me a mass of 0.204 grams of sodium bicarbonate. So my percent yield, 0.204, my percent composition, 0.204 out of 0.3 times 100%, oops, is we're looking at about 68% of that antacid tablet is actually the sodium bicarbonate.